Okay, so now I am going to tell you the theory of recursive functions. So first I will tell you the theory and then I will write a C programming code so that you can understand. So first of all, what is a recursive function? So this is a function which calls itself. That means if you see a function is calling itself, then you will call it a recursive function. Let me give you one simple example. Let's say we have a function of n which is taking the number from n to 1. That means this function is taking the number from n to 1 and doing the summation. But now I have a question, then what this thing is doing? This thing is taking the summation from n minus 1, and that's why we can say that this is f of n minus 1. Simple. F of n is taking the sum from n and f of n minus 1 is taking the sum from n minus 1. Then let me write this n here and let me write this f of n here. So I have obtained a different representation of f of n. If you look carefully, this function is depending on the same function. That means you have to find, if you want to find f of n, you have to find f of n minus 1. So this function is dependent on itself. So how we can write the function in write this function in the C code? So first of all, we have to write the main function, and inside this main function we have to call this function. So let's say you want to find 3 plus 2 plus 1. That means if you put 3 here, then the output will be 6. Okay, so that means you have to call this function. So let me write this function here, and this function is taking some number n, and for this example n is equal to 3, and inside this function you may have some code. So every function, actually not every function, but most of the function returns something, right? So the question is, what should be the return value of this function? You can see that this function is equal to this thing. So this is actually the return value so of this function. So let me write here this thing, n plus f of n minus 1. You can see that whatever is here, I have written that thing here because this thing is equal to f of n. So this should be the return value. But if you see carefully, it again call f. That means in this line it is again calling the same function, and that's why it is called the recursive function, because it is calling itself again. So let me write this thing here. So that means this function is calling the same function f, which will take n. But the question is now, what is the value of n? You can see that here n is equal to 3. So n minus 3, this function is sending n minus 1. That means 3 minus 1, that means 2. So this function is sending n minus 1, that means 2, and this function has received this 2. This both functions are same, but I have written it separately so that I can understand this, I can make you understand the signal flow. As these two functions are same, that means the same code will appear here, the same return code will appear here, and you can see that this thing is again calling the same function where n is equal to 1. Now you can see that this function is calling itself, again calling itself, again it will call itself. That means this function is repeatedly calling itself, calling itself, calling itself. If we don't write a code to stop it, it will forever calling itself. So we have to write a condition. So we have to write a condition to stop repeating itself, stop calling itself. So what is the condition? First of all, tell me the range of n. What what the, what is the range of n? N may be 1, n may be 2, n may be 3, n may be 4 dot dot dot. Then what is output? If n is equal to 1, then output will be 1. If n is equal to 2, then output will be 2 plus 1. If n is equal to 3, then output will be 3 plus 2 plus 1. That means you can see that we can take the value of n from 1 to infinity and our output will looks like this. So what is the minimum of this range? When n is equal to 1, the output is equal to 1, right? So I need to write this thing. Why? You can see that this value is decreasing. First n is equal to 3, then n is equal to 2, then n is equal to 1, and the minimum of the range of n is 1. So I have to write a condition at first, and the condition looks like this. If n is equal to 1, the minimum of this range, then what will happen? It will return the output. And what is the output? For n is equal to 1, the output is 1. That means you have to return 1. Now my question is, these three codes are same. That's why the same code will appear here. So you have to write the same condition here, and you have to write the same condition here. That means when n is equal to 1, you have to return 1. But if you can say that n is equal to 3, that means this code will not be satisfied, this condition will not be satisfied, and this code will execute. Similarly, for this line, n is 1, return 1. So you can say that this condition is again not satisfied because n is equal to 2. So we will the function will ignore this line and execute this line. But you can say that now n is equal to 1, so the condition is true, and now this return will be successful. Now the question is, as these three codes are same, this line is also appearing in this line. So my question is whether this line will be executed. The answer is no. Why? Because once you get a return, the function does its job. The function's work is to generate and return an output. If you return 1, then this line will be ignored. So if n is equal to 1, it will return 1. Now the question is where this 1 will be returned. So I will again question you that from where this function has been called. You can see that this function has been called from here. That means this return value will be received here. That means this value is 1. And what is the value of n? You can see that n is equal to 2. So let me write here 2. So 2 plus 1 is equal to 3. And you can see that this 2 plus 1 is equal to 3 is again return. So where is it returning? So I have to question you again, then from where this function has been called. I can see that this line is calling this function, so the return value will be returned here. So this thing will be 2 plus 1, and what is the value of n? N is equal to 3. You see, n is equal to 3. And again this 3 plus 2 plus 1 is returned where? So I have to question you again, then from where this function has been called. The answer is from here. So this 3 plus 2 plus 1 will be returned here. And then if you put this answer in another variable, then if you print the value of b, you will get the answer. So this is the algorithm of the recursive function. Thus the recursive function works. So now let me tell you how to write the code. Go to your browser and search one compiler. Then go to one compiler. If you scroll down, you can see here C. So here you can program C, write the code C, or you can use VS Code or code blocks, whatever you want. Okay, so this is the node I have written previously. So what is our algorithm? So you can see that this is our main function. So inside this main function, I have to call this function, and I want to find 3 plus 2 plus 1, and that's why I need to send 3. Okay, so I have to write this function here. So let me write this function. This function will take an argument which is n, and then it will return what it will return. You can see n plus f of n minus 1. So n plus f of n minus 1. So this is the return value. And again we have to write the condition so that it can stop calling itself. So let me write here the condition if n is equal to 1, then you have to return 1. So after returning 1, it will not go to this line. So this is one recursive function, and you can see it is returning 1. It is an integer, so we have to write the type of the return value here. Okay, so let me write this code now. So okay, one more thing. So the return value, I have to receive this return value to another variable b, and let me declare this variable here float b, and then I need to print, sorry, it is not float, it will be integer, and then I need to printf %d for integer b. Okay, sorry, here is semicolon, and now let's see what happens. So you can see the final answer should be 6. 3 plus 2 plus 1 is equal to 6. So what is 4? If I send 4, then the result will be 4 plus 3 plus 2 plus 1, that means 10. Yes, the result is 10. And now if you want to understand the signal flow means you can see that first this line has been executed, it calls again, it calls it again, then you see a back propagation here, a back propagation, this one is received by it, then this thing is received by it, then this thing is received by it. So if you want to understand the forward propagation and the backward propagation, this forward and backward propagation is not any official language, I am telling it because I am I studied deep learning, machine learning. There I have deep learning, neural networks. There I have forward propagation, backward propagation. That's why I calling this term. But this is an unofficial language. Forward propagation, backward propagation, whatever. So let's say you want to understand the signal flow, that how this thing is working. So what you will do? Let me see what this value is return. If I mean, before executing this line, let me give you, let me tell the user that, hey, this code is saying, hey, I am returning 1. And again, in this line, printf, tell the user, let me write here one new line. And here, let me tell the user that, hey, I am returning. Let me do one thing first. Let me write this f of n plus f of n minus 1 is equal to x, and then let me write this thing and put this thing into x. The same thing, I'm doing the same thing, just in different way. Why I am doing this? Because after executing this line, before executing this line, let me call the user printf, hey, this code is telling you, hey, I am calling f of n minus 1, and And what is n minus 1? So let me write here %d, then write this thing fn minus 1 here. Then after receiving the value, I need to know what is the value of x. So let me write here printf. The code is telling you that hey, I have received what? X. I have received x. So x is a integer type variable. Okay. Now here you have to write another line before returning. Tell the user that hey, I am returning what? N plus x. So it's also a %d. Then write here n plus x. And again at the beginning, user may want to know that what is the value of n. So the value of n is %d then n. Okay, so this is the full setup, and let me write here new line, new line, new line, new line, new line, and let's see what happens. So you can understand the signal flow, but what's happening, let's see. Oh, x, I have to declare this x first, so integer x. Now let's see what happens. Okay, let me do this for 3 and let's see what happens. So you can see that this function is calling this function. That's why n is equal to 3. This line is executed. N is equal to 3. Then this condition is not satisfied. That's why I am going to this line. What this line is saying? I am calling f of 2 and then it calls f of 2. Now this function calls itself again. Again it goes here and print the value of n. Now the value of n is 1 because you see it calls itself with the value of 1. And when sorry, let me do the let me tell the thing again. So first of all, from the beginning, first of all, f of 3, this line is calling f with the value of 3 and that's why n is equal to 3. Then this line will not be executed, this line will be executed. This is telling that I am calling f of 2. Then at this line f of 2 will be called. Okay, if f of 2 will be called, again you will jump to this line which is telling hey, n is equal to 2. Again this condition will not be satisfied, so these few lines will be executed and this few lines is telling you that hey, I am calling f of 1. Again it will go here and n is equal to 1, you can see. Now this condition has been satisfied and this line is telling hey, I am returning 1. So you see I am returning 1. So after returning 1, where this value will be, you see that if you return 1 you will receive here. So after receiving this value, you see here you have printed that I have received 1. And then what you have done, that after receiving 1 at this line, you are printing that hey, I am returning n plus x. So what is n plus x? n plus x, what is the value of n plus x? First of all, value of x is equal to 1 because it received 1. But what is the value of n? Okay, let me go here. So let me go here. You can see that return 1, right? You see return 1. Now you go here. So then 2 plus 1. So what is the value of n here? 2, and you have written 1. So now at the whole what you are returning 3. So now you can see that this line is returning 3. Where it will return? It will return here. I mean in this line. So after going to this line and this line, you see that I have received 3, return 3, and that is received by this function. I have received 3. Again you will go to this line, and what this thing says, n plus x. I am returning n plus x. So what is the value of n? N is 3, and this is 2 plus 1, total is 6. So I am returning 6. And where this thing will go? This thing will go here. So this is the overall signal flow. And if you write this code, take some time, do experiment with yourself. The best way of learning code is to do experiment. Is to do experiment. If you want to understand the signal flow, you can put many printf functions in many lines and then see what happens in the code. Okay, so that's all. Thank you.